Ours is a circus show for children. We have two characters, a knife thrower who throws balls instead of knives, an elephant that recognizes objects and carries out actions based on the object, interacting with the tamer and teaching children to brush their teeth. The material is 90% recyclable excluding the electronics and a small part in plastic. The rest is made up of wood, aluminum and paper. The programming languages used are Python with OpenF and libc++ for Arduino. The launcher is composed of Arduino Mega, 4 servo motors and an ultrasonic sensor. We use 7.4 volt LiPo battery power supply and a voltage regulator. The mechanism consists of 2 servo motors, a small wooden piston and a rubber band. The first feature, throwing the ball in front of the elephant, choice because we find it interesting to be able to control the landing point of the ball, and this can create interesting show situations. We studied the motion of the projectile. First we calculated the speed of the ball by seeing the different ranges at different angles of inclination. Then we adapted it to our purpose. We find distance from our target with an ultrasonic sensor. We modify the angle of inclination to reach the desired distance. Having constant speed and being able to throw the ball in a precise point, we can make a basket simulate a circus knife throw and pass the ball to the elephant. We use the launch to make the two robots communicate. Through a colored ball, the launcher communicates to the elephant the moment to enter the scene. The elephant recognizes the ball with computer vision. The elephant has a STF401 Re-Core board with 6 driver motor controls, 12 linear actuators. For the length of the pistons we use your sensors as optical encoders. An Arduino Mega instead controls the 5 servo motors for the movement of the proboscis. A laptop with camera external is the brain of the robot, powered by an 11.1 volt LiPo battery and a voltage regulator. We built an optical encoder by coloring the piston of the linear actuator in black and white and reading with an IR sensor, thus being able to define the point where the leg is perpendicular to the ground. The second feature is the elephant walk, because we know that children, our target, like them a lot. The walk takes place through the 4 legs with 3 degrees of freedom. Each linear actuators move the center of gravity by raising 1 or more legs at the same time, trying to bring the center of gravity down to the support area, an area that allows you to maintain balance. In previous experiments, this support area was too small due to the legs and did not allow for good balance. We have 3 AI-based working with computer vision. The first serves to recognize objects using the YOLO library, which is based on a pre-trained done on the COCO dataset, of which we have chosen some objects. The third characteristic is this: based on the object he sees, he carries out an action. Therefore there is no linear but variable script. With computer vision we recognize the colors with the OpenF library, both to recognize the ball to start the show and to collect the bottle with the gripper marked with the green color. Object-related actions are toothbrush, brush teeth, bottle, reaches for the bottle and drinks, then drops the bottle, scissors, with the gripper simulates a scissor. The fourth feature is a reinforced learning totally created by us to move the pliers towards a glass and release the toothbrush. The image captured by the camera is seen as a matrix 10 by 10. We train the AI by giving a positive mathematical weight to the movements which brought the gripper, green tag, closer to the glass, blue tag, and negative those which moved them away. Hand gesture using DLib library. We trained a SVM machine learning with hog filter to recognize our hand gestures and move the proboscis on the tamer's orders. For the aesthetic part, we built a grid to create the shape of the elephant and covered it with paper and glue to make it solid but keep the movements. Then we colored and finished it graphically.